a sampling distribution for a difference in proportions. So with this, we're going to start out with talking about the three things that are going to be crucial to solving these types of problems. So we're going to talk about the shape, center, and spread. So we're going to talk about the shape, depending upon how we calculate what the shape is going to be. Talk about our center and how we calculate that guy, as well as the spread, or as you hopefully recall, is your standard deviation, right? So shape, center, and spread of the sampling distribution. Okay, so with the sampling distribution in this case, now we're going to be talking about not just our p hat, our sampling proportion, but the difference in it. So we're going to take whatever we classify as our p hat 1 minus our p hat 2. Alright, so with this, starting out with our shape, again, as you've known with proportions, we've dealt with the large counts to determine if we're approximately normal, okay? So we've got approximately normal if our large counts is met. Now, we've just dealt with one sample distribution so far. So with this, we've got to now check it for both proportions, all right? So both samples, in other words, so you're going to have two samples that are coming into this. So you not only have to do it for the first one, but the second one as well. So you're going to take N1 times your P1, and then you got to take N1 times your 1 minus P1. Both those have to be greater than or equal to 10, as well as you have your N2 times your P2, as well as your N2 times your 1, oh goodness, if I can write here, your 1 minus P2, and both of those also have to be greater than or equal to 10. So for this to work out, for be approximately normal, for your shape to be approximately normal, this has to check off, and this one, both have to work. Okay. So now, if we look at this, it's dealing with our center. Alright, our center. Again, if you remember, we said the mu in past here, I'll write it. In the past, we've said our mu of just p hat is equal to p, right? Well, that goes pretty much the same way here, except now we've got to talk about it being in a difference, okay? So now we've got to talk about it being in a difference. So in other words, we're going to take, looking for mu of our p hat 1 minus our p hat 2. So the mean of our sample, right? We're going to take proportion 1 minus proportion 2. And the last thing we need to talk about, start out with this lesson, is dealing with the spread. Well, if I can spell here, erase that. With our spread, okay? So with our spread, we're going to be talking about our standard deviation. But now instead of just, we're talking about our one sample p hat, we're going to take our, talk about the standard deviation of the difference. So our p1 hat minus our p2 hat. And to calculate this, since we're dealing with proportions, we would take p times 1 minus p divided by n normally to find our standard deviation. However, to find the difference, we're going to take P1 times 1 minus P1. It's poorly written. Let me write that again better. 1 minus P1 all over N1, so dealing with your first sample, plus P2 times 1 minus P2, all divided by N2. Alright, so this is not a mistake as far as putting this plus sign here. Okay, a lot of people see that this is a difference and don't like that, and they think it should be a minus sign, but it's actually a plus sign. Okay, it is a plus sign in here. That is just the formula they came up with to do our standard deviation and the difference. Okay, well, not that they came up with, that was developed and found out doing our math calculations. Okay, so when this was discovered that the plus sign works here, that is how they use the standard deviation and the difference proportions. So with that, that is the formula that you don't necessarily need to remember because it should be given to you on your formula sheet. However, just understanding of that it is a plus in here when you're doing the calculations. Alright, so let's look at an example and see how these play out and how it's going to be presented in a problem.
Hi, this is Jason Molesky. In this example, let's take a look at the sampling distribution of the difference of two sample proportions. Suppose your teacher brings 2 bags of colored goldfish crackers to class. In the first bag, suppose we have 25% red crackers, and the second bag has 35% red crackers. Now each bag contains more than 1,000 crackers, and suppose using a paper cup your teacher takes a simple random sample of 50 crackers from bag 1 and a separate simple random sample of 40 crackers from bag 2. Let's let p hat 1 minus p hat 2 be the difference in the sample proportions of red crackers. Now what's the shape of this sampling distribution? Well, because n1 p1 is equal to 12.5, n1 times 1 minus p1 is equal to 37.5, n2 p2, our sample size for the second bag, times the proportion of red crackers is 14, and n2 times 1 minus p2 equals 26, they're all at least 10, so we know that the sampling distribution will be approximately normal. Now, to find the mean of the sampling distribution, we use our formula mean of p hat 1 minus p hat 2 is simply p1 minus p2, 0.25 minus 0.35, or negative 0.10. So the average difference in means if we were to take lots of different samples would be negative 0.1 if we were to subtract p hat 1 minus p hat 2. Now the standard deviation of the sampling distribution can be found using our standard deviation formula. Because there are at least 500 crackers in bag 1 and 400 crackers in bag 2, we can use the formula, plugging in what we know about bag 1 and bag 2, and find it to be 0.0971. So in the long run, while we'd expect the difference between the sample proportions to be negative 0.1, we'll expect it to vary 0.9 on average.
Alright, so after watching that example, hopefully you saw how they came up with the shape, center, and spread based on the problem presented to them, in which case you're dealing with your large counts for your shape, dealing with your first proportion minus your second proportion for your center, and then your spread is done with that equation for your standard deviation and the difference. Alright, well, hopefully you learned a little bit something today, and I'll see you next time.